So if you didn't notice, when you were looking at your tests, there were two versions of the test. The second test, I often give two different versions of it. All the questions are essentially the same. It's just that the words and the numbers are just a little bit different. So as I go through the questions on the test, note that there are going to be two different answers. One that represents your test, and if there's another number there, that represents the other test. Okay? So bear with me to some degree. Okay, so what was available on the test, depending on which test you had, right? So you either had 20% or 80%, and then you either had 10 or 12, and then you either had 5/6 or 1/6, and then you either had 2 4/5% or 4 1/4%. And then you either had 0.002 or 0.006. So the red is the stuff that you guys were given on the table. The blanks were what you had to fill in. So, converting to decimals, either 0.2 or 0.8. And you had to be explicit with the decimal point. If I couldn't see it, I marked you wrong. That's the way it worked. This is 2/10, simplifies to 1/5. This is 8/10, simplifies to 4/5. What does the sentence on the top of the test say? Do not round anything and simplify all fractions. So if you did not simplify fractions, folks, it was just wrong. That's all there was to it. It's either right or wrong in this section. And then converting these 10 and 12. Either way, you can leave the number as is or put it as an improper fraction. That's okay. As a percent. Remember when you're converting decimal 2%, you multiply by 100 or move the decimal to the right. So 10 is 1,000%, etc. Again, then dealing with the next row, dealing with the fractions. You needed to tell me that was a 0.16 repeating or a 0.83 repeating. I wanted to see the repeating bar. I was a little lenient on a few people who put like ... after the 3 to indicate that there were more 3s. I gave that one to you. That was not usually something I would have done in the past, but I gave it to you this time around. And then when you convert these into percentages, 16.6 repeating or 83.3 repeating percentages. Again, don't round anything, so those repeating decimals stay repeating. If you wanted to, technically this is 16 2/3%. This is 83 1/3% if you converted it. The next row, more than 20% of you did it.
Is that a good thing or a bad thing?
It's a bad thing. So I had a lot of people who looked at this and said, oh, it's 2.8, and wrote down 2.8 for the decimal. This is 2.8%, which is 0.028. 4 1/4, this is 4.25, 0.0425. So I had a lot of people who just converted the fractions into a decimal and then didn't bother to deal with the percent sign. And that's the thing that I've been saying. 20% of you are going to do anyways. You were going to write this number as 2.8 or this number as 4.25. And
Yep.
there were a good 23.5% of you that did that. And if I include the online class, because the online class, by the way, gets the exact same test as you guys, the percent, about 40% of them just did it. You guys were better than the online class. Thank you. Okay? That was. And then converting these.
Oh, I see. So basically, they move the decimal. So you're saying for that one, they basically take the percent and just move it over, so it'd be like 4.5
it wouldn't
Oh.
actually convert the decimal portion.
Oh.
They would convert the fraction here to a decimal, but then not worry about the percent sign or forget about it and just write 4.25 or 2.8.
Oh, okay.
And that's what I was trying to get people not to do. But they still do it. So, and again, I still haven't figured out the right way to present it so that less than 20% of the class does it.
You should have them rewrite it. Like, that's what I did. Like, you,
Yeah, like somehow convince them to write this as a percent
yeah,
without
write that
fractions or
as a
something.
percent decimal.
Right.
And
then convert.
That's what you should tell
The sad part is I had people who wrote 2.8% and then wrote 2.8.
them.
Over half of the online students did that, straight up. They wrote it as 2.8% right
Maybe
next
because
to
they're
it.
moving the, I
Don't know. Don't know. Again,
don't know.
it's frustrating, so
Decimal.
I will try and think of a new way to do it next semester. I will probably go back to singing, I think.
Move the dot. That's how I remember.
Alright, so then the last one, you either had 0.2% or 0.6%. Again, you move the decimal to the right. You had to make sure I saw the decimal point in the percent sign right here. And then these, 1/500th or 3/500ths, depending on which one you had. So folks, that was the first question. It was 10 points and you were either hit or miss. You either got it or you didn't in each box. So note, this is usually not a question on the final exam, folks. Okay? You will have to do enough converting of decimals and percentages and fractions and whatnot that this is not something I usually put on the final exam. So I could ask this, but I haven't in the past 10 years. So just so you know.
How many questions will be on the final exam, or
Yes.
pages, whatever?
Yeah, there's 4 pages.
Is it the same setup like this?
Yep.
Oh, okay.
All right. So then, question 2. Again, the way that question 2 worked is it was worth 10 points, folks. The way it worked was that the first problem of the 3 that you had there that you did correctly, that question was worth 4, and then the other 2 were worth 3. Okay? So the total of the points had to add up to 10, but whichever one you did correct in A, B, or C, that was the one that was worth 4. Okay? If you did the first one correctly, that one was worth 4. If you didn't, then I made the second one worth 4. Unless you did the third one correctly, then I made that one worth 4. So that actually was a floating point determination. It was my way of trying to give you guys as many points as possible, right? Because if you did any one of those 3 correctly, that was the one that was worth the most points. Okay, that's the way I always do it, so that you guys get more points rather than less. So depending on which test you had, you either had 225% of 150, or you had 180% of 20. So if you did it is over of, if you did it through multiplication, all you have to do is convert the decimal, the percent to a decimal. So if you had the 180%, your answer was 36. If you had the 225%, 337.5. And again, it's cross multiply and divide. Right? So you multiply the 225 and the 150 and then divide by 100. Part B. Of 50 is 225, or you had of 80 is 120. Find the percentage. Again, the key to this one is that the of is the smaller number. So if you did it is over of, you have to put the of below and the is on top. The x is the percent. solve this one. 450% here if you divide by 80. And then you have to convert that to a percent, 150%. I was nice, folks, if you didn't write the percent sign, I just wrote it in for you and gave it to you, didn't worry about it. Sometimes I get anal about that, but I wasn't this time around, just so you know. And then last but not least, part C, the small percentage problem. 8 is 0.05%, or 4 is 0.02% of. The key here is that now it's 8 over x equals 0.05 over 100. Note, folks, when you do is over of, you don't convert any of your decimals, right? So even though it's this 0.05, you don't move it or anything like that if you're doing is over of. If you're doing the PDR technique, then you do move it, right? So there's the difference between these two techniques, right? When you're dealing with is over of, there's no movement of the decimal point. When you're doing the PDR or the translation technique, then you do. Again, depending on which one you had, 16,000 or 20,000. And again, with this small of a percent, to get this big of a number, you needed a really large number to start with, right? So it had to be up there in that big value to get a really, really teeny decimal percent. Again, 2 of the questions were worth 3, 1 of them was worth 4, and it varied depending on which one you had. So, I tried to be nice. If you did things that were sort of on the right side of things, I tried to give you a point. Again, I try very hard, folks. If you show me your work, to give you a certain amount of partial credit based on what I see. All right, so then number 3. Oh, I warned you about number 3. So, depending on which one you had, you either had a 22% down and you owe $31.20, or you put 24% down and you owe $22.80. All right, the key to these two, folks, is if you put 22% down, folks, what percent do you owe?
80. It's rough right there, too.
And if you put 24% down, then you owe 76%. And so these are PDR problems or is over of problems working off of these.
So that's the same, like, what is 24% of $3,000, right? I had the one on the left. Right. The one on the right.
You had this one?
Yeah.
Well, yeah, because you found out what the number was before, right?
Okay.
So you said, oh, I know that 76 over 100 equals 2280 over x, right?
Yeah, that's how I checked that. I just wasn't sure if it was right or not. I was like, hopefully you don't think this is not work.
No, that's perfectly okay. The other way around doing this one, folks, is to say 3120 equals 0.78 times the base x. And so the key here is that, yes, you need to divide by the complement of your discount. The key here was that I was looking for you not to add, and what most people did in this problem, that when they did it wrong, was they said, oh, take 22% of this number and add, or take 24% of that number and add, and that's just, you cannot make a percent decrease problem work like a percent increase problem. That will never, ever work. So if you did that, if you did it that way, if you added numbers, I only gave you a maximum of 4 points on the question. If all you did was divide, then you started at 5, and then if you did it correctly, I could get you to. And the numbers worked out to be very nice, folks, right? You either bought a $3,000 riding lawnmower or a $4,000 riding lawnmower, because 22% of this is going to be the $880 that you put down, right? 24% of this number is going to be the $720 that you put down, right? I mean, that was sort of the key behind those problems. Folks, this is very often a final exam question, okay? Because it's a good question, right? And it's real, because this is how it works, right? I mean, if you go somewhere and say, I'm going to put 15% down, they're going to say, well, you still owe us, X amount of dollars, and you should be able to work anything out about the problem when you have that piece of information. So, it's a good problem. Again, it forces you to think about how to deal with these sorts of problems without resorting to the traditional, just multiply and add or multiply and subtract technique. All right? So, do not be surprised when you see that one repeated. All right, so then number 4. All right, so you either had, I have $200 and have 12% less than my brother, or I have $140 and I have 60% more than my cousin. So depending on which test you had, you either had percent less or percent more. And the key to both of these was that when you had 12% less, you did not add. When you had 60% more, you did not subtract. All right? Because in these problems, percentage increase, percentage decrease, you are always either going to subtract or add, depending on which one it is. Right? So here, new is equal to old minus rate times old. 200 equals x minus 0.12x. $200 is 0.88x. If you take 200 divided by 0.88, my brother had $227.27. If you just took 12% and added that, I gave you 4. Because you read a percentage decrease problem and said make it an increase problem? No. Just no. Alright? And likewise over here, old plus rate times old, because this is a percent increase problem. So 140 equals x plus 0.6x. 140 equals 1.6x. Divide by 1.6. $87.50. Again, if you took 60% and subtracted, that got you 4. Because you cannot do subtraction in a percent increase problem, and you can't do addition in a percentage decrease problem. So, again, these are going to show up on the final, folks. You should put a little star next to these and make sure that you remember them, because they will definitely show again come final time. All right? All right. And then number 5, you were either buying a Rolex or you were buying a new Trek bike. So you're either buying a bike that was $249 and is now $678.75, find the percent increase, or you were dealing with a Rolex that was $299.99 and is now just $99.99. I'll need one of those at the end of class. Now, how do we do percentage change, folks? Difference divided by where you started. So you need to subtract the two numbers, 678.75 minus 249.50, and then divide by where you started, 249.50. And then likewise over here, 299.99 minus 99.99. All over $299.99. So again, you take the difference of the two numbers and divide by wherever you started. Okay? So this 429.25 over 249.50, 1.720440882. Again, please remember that this comes back to you as a rate. You need to convert it to a percent. $172.04% on the increase side. Over here, you're going to get 200 over 299.99, which is 0.6666889. Again, that's a rate. Move the decimal over twice. 66.67%. And again, the idea behind these sorts of things, right, is that this number is basically 250, right? This price more than doubled, right? Therefore, this number has to be more than 100%, right? And it's less than $750, which means it didn't triple, so it has to be less than 200%. That's one of those concepts that you should start getting used to in your brain. Likewise over here, $299.99 to $99.99. This is basically $300 to $100. Is that more than half? You bet it is. Is my number more than half? You bet it is. Okay? Those sorts of quick checks, those are the sorts of things to make sure that you did the numbers the right way, right? So, there's usually one of those on the final exam too. So basically what I tell students is that of those three problems that we just did, 3, 4, and 5, 2 of the 3 show up on the final exam. Right?
Will this one be on it then?
Potentially. 2, like I said, 2 out of the 3 for 3, 4, and 5. I generally, what I do is that I ask somebody in my office, pick a number between 1 and 3. Whichever number they pick, that's the one I don't include on the final exam. And all I do is copy, paste, change numbers, change 2 words, done. Like I said, I'm inherently lazy when it comes to writing tests because these questions are all awesome questions. There's nothing wrong with any of them. If you see them twice, and if I just change the word from Rolex to necklace, $299.99 to $99.99, yes, that makes complete sense, no problem, right? So it's real easy for these words to basically change and the numbers to be off by a little bit so that all the values are a little different, but the process is still simple. All right, so anyways, that was 5. All right, then number 6. Oh boy. I think, in general, I think you guys did good on number 6 if I look at the numbers. Yeah, I mean, you were above 70% on this particular page. But, again, it's a little bit on the... I tried to be nice, folks. Note that in both of these problems, I bolded which type of markup you were working with, right? I will continue to do that on the final exam so that you know which one you're working with to be safe. Again, this is part of that issue, right? Just making sure you use the correct one at the right time, right? So, if you had the first question where you had a painting that was $125.40, and I said mark up 185% on cost, and then I said find selling price, or you had the other test where I said I'm selling a painting for $114.28, and I mark up 240% on cost. And this one I said find the markup. Okay. And I tried to be nice over there in that first one, and this problem right here, the 114.28, said, hey, find the cost first, then tell me what the markup is, right? On the first one, if you're marking up on cost and you're given the cost and the markup, this was a straight application of that formula. The selling price is the cost times 1 plus the rate, because this is markup on cost, right? So you can just plug it in. 125.40 times 1 plus 1.85 Selling price was $357.39. Not too painful. Now this one was a little bit trickier. I gave you a hint that said find cost first. When you are given the selling price, you find the cost by doing selling price divided by 1 plus rate, because you're marking up on cost, right? You have to use these formulas, the 1 plus rate formulas. So this is 114.28 all over 1 plus 2.4, because 240% is 2.4, just move it 2 places. And so the cost winds up being $33.61. And then the way I found the markup was just saying, hey, I know the markup is the selling price minus the cost. 114.28 minus 33.61, $80.67. If you did the markup by calculating the cost times the percent and got $8.68, I gave it to you because I'm nice, even though the numbers don't add up. Because that's okay as well, all right?
Even if you gave us the points, would you have marked to show us what we did wrong?
You didn't do anything wrong. It's just that in the end, you want the numbers to add up. You want the selling price to be the cost plus the markup. And the wrong is that this 33.61 is rounded, and when you multiply by 2.4, that introduces a 1 penny rounding error. So it's not wrong. It's just an affectation of the math. That's why I marked it wrong for it. So even if you had $80.68, as long as you showed me your work, I could say, oh yes, I see. Good, check. All 5 points. And again, A and B, 10 points, so each half was worth 5. So on the next question, on part B, the first test got the complicated one, right? Where you ordered a statue that's $95.22, and the markup is 62% on price, and I said find the markup. On the other side, I said, oh, I'm selling a statue for $193.72. My markup is 46% on price. I said find the cost. So now the first test has to do the funny game where it takes a little bit of work to figure out what the selling price is. So here, when you're given the cost and looking for the selling price, when you mark up on price, here's the formula for finding the selling price from cost. When you're marking up on price, so you got a 95.22 all over 1 minus 0.62. And that gave you $250.58. That's the selling price. The cost was $95.22. And so your markup was $155.36. So again, I always did it through the subtraction. If you wanted to, you could have taken the markup 0.62 times the selling price, $250.58. That would actually round it correctly that time. And then over on the other side, if you had the easy question this time, when you're given the selling price and asking for the cost when you mark up by price, there's your formula. So you can just punch in 193.72 times 1 minus 0.46. to get your cost of $104.61.
I think they just now got their test back.
Did they get them? Did you guys get them? Did you guys get your test back? Yes.
Someone just came in and
Did they came in and give them to them? Okay. So you guys can catch up now. All right. There will definitely be a question like this on the test. A markup on price and a markup on cost question on the test. It will be 2 parts, just like this one, exactly the same, because this is the Chapter 8 question. That's of importance for the most part. So no ifs, ands, or buts about there. Question 6 is on the final exam, period. That's all there is to it. Just like number 7, there will be a question number 7 on the final exam, because that's chapter 7, right? All of the chain discounts and term discounts as to when you pay, etc., etc. So, the only difference between the two questions, folks, was one test had 600 pots at $1.95, the other one had 400 pots at $2 1/4. Otherwise, the two tests are exactly the same, right? All the numbers are totally different, but the starting point for everything is off just a little bit, which is nice. So I can give you two different questions, even though they're essentially exactly the same. All right, so the first thing I asked for was the single equivalent discount rate. The single equivalent discount rate, first thing you have to do is calculate the net price equivalent discount rate. So multiply by the complements. 819298. If you told me that was the single equivalent discount rate, I only gave you 3 because that's the net price equivalent rate, folks. To get the single equivalent, you have to do 1 minus that. So basically you're getting a 26.9704% discount from those 3 discounts, 19/8/2. So that's the same for both tests. For part B, I said find the net price. Finding the net price, folks, that's just multiply the number of items times the price, and then multiply by your net price equivalent, right? So 600 times 1.95, that's the 1170, right? 0.730296. $854.45 for the one side. Times the 0.2 set, little going with that. 657.27. And all that is figuring out the list price, 900 to 1170, and then multiplying by the net price equivalent, right? And note, folks, when I graded these tests, I tried very hard to make sure that one part of of this question didn't affect the next one. Right, so each part of the questions, even though they were all tied together, as long as you did the right thing according to the question, if your number was completely wrong, you could have still gotten all the points if, based on where you came from, you did the right thing. Okay? So, just realize that your numbers may wind up being wrong on your test, but you still got all 5 points for the problem. That's just because you did the right thing, but you started from a number that was wrong. Okay? So, part C basically says, okay, I made a payment on September 22nd. First off, what's my discount on September 22nd?
2%.
4%.
Oh, yeah.
Because it's still within 10 days of the invoice date, right? So remember this 4/10, 2/20, N/90, everything is based off invoice date. The invoice date's the 12th, the 22nd counts. Okay? Now, what you do with that 4%, you have to take your payment and divide by the complement of your discount.
Okay, so on my thing, I wrote like this little shebang, and you put round correctly always.
Yes.
So like when you do that, you get like 3, like all repeating.
Yes.
So you wouldn't round it because after the 100th place, it's another 3.
round it down to
Okay.
3. And
That's what I was asking, so I thought like,
yeah, so round correctly always.
okay.
So if what follows this 3 is a 3, it stays a 3. If what followed this 3 was a 7, you go up to 4.
So what if like when you're like doing like selling cookies,
Mm-hmm.
you have to round up to make sure that you make your profit, right? Like meet your money.
Yeah.
But if you round up to make that exact dollar amount needed, is that still
Yeah.
okay?
I was okay either way. Let's put it that way.
Okay.
The key though, folks, is that this 208.33, that's the number that you should be subtracting from your net price. So what I was looking for was you guys making sure that you went back to the net price of $854.45 and subtracting 208.33, or the $657.27 and subtracting 208.33. So there was like 3 points for doing this whole part correct, 1 point for getting the discount correctly, 2 points for doing the division correctly, and then another 2 points for making sure that you subtracted sort of the right way. This is why there were variant numbers floating around here between 2 and 3. But this, we were down to 646.12, or we were down to 448.94, depending on which test you had. And no, folks, there would definitely be a partial payment question on the final exam, guaranteed, right? 100% guaranteed. So you need to remember how to divide by the complement when you're getting one of these partial payments. And then last but not least, on part D, pay in full on September 27th. On September 27th, folks, we're getting a 2% discount. When you pay in full, you just take 2% and subtract. Or multiply by 0.98, right? So this one was the 633.20. And then the other one, if you took 448.94 times 0.98, you owed 439.96. And note, folks, on the last question, as long as you took 2% off of whatever you had in answer C, you got all 5 points, right? Because all I was making sure for this last question was when you go to pay in full, note that you got a 2% discount and note that you're paying off whatever is left over from what you paid in Part C. So that's why your number may be nowhere near either of these two numbers, but you still got 5 points for the question, okay? Because the question was really asking, do you know that you're supposed to take 2% off? All right. So probably not as long of a question on the final exam, just so that you know, but similar. All right. All right. So then the last page. So question number 8 with count the money, or count the monnaie. If you know any history of the world, part 1, this is count the monnaie, except the subject's always called him count the money, and so he's like, no, not money, monnaie! It's a great joke if you've ever watched the movie. Anyways, so depending on how you did things, right? So you either started at $880 or you started at $775, and then you did a 25% discount, you did a 38% discount, and then 120% markup, or you did a 40%, 22%, 110%. So I was hoping you guys would take the shortcut. When it's discounts, you multiply by 1 minus the rate, right? When it's a markup, you multiply by 1 plus the rate. And if you just multiply these 4 numbers, you will get to your answer in 1 step, okay? That's the shortcut technique for doing this problem. 880 times 0.75 times 0.62 times 2.2 would give us the $900.24. I actually gave people extra credit if they did it that way. No one did. Everybody did it the long way. Everybody took 25% off and then 38% off and then 120% and added. And there's nothing wrong with that, okay? And I was also giving partial credit for doing that. So if I saw the number 660 somewhere, I was like, oh sweet, that's worth 2 points. If I saw the number 409.20, that was worth another 2 points. Awesome, right? Then the problem that I had, right, is that technically, this is what I saw most people do. Right, this was $490.80, right? And they told me that the final price was $490.80. That's the markup amount. You're marking it up by $490 because that's 120% markup. This needs to get added back to over there. Oh, and I guess it's $491.04 or something like that. Because technically that needs to get added. And that's what gets you the 924. So if you didn't remember to add this one, then you only got 1 point for that, and you wound up getting 5 on that portion of the question, right? So 2 here, 2 here, and then technically you were getting the rest of the points, the rest of the 4 from that particular portion. If you didn't add, then you only got 1. That's why you got 5. But whatever, I wasn't unhappy per se, but I was like, oh, bummer. Okay, and then on the other side of the coin, if you were doing the other portion of the test, right? 775 times 0.6 got you to 465. 2 points if I saw that number. 465 times 0.78 is 362.70. There was another 2 points if I saw that number. And then last but not least, 362.70 times 2.1 gets you 761.67. That technically was the final answer that I was looking for. And the cool part about it was that, you note in one of the problems, the price of the painting actually went up by like $20. But notice in the other problem, what ended up happening? It actually went back down, right? I mean, it never got back to 775, right? And this is where that whole, multiplying by complements and multiplying by 1 pluses didn't make it enough to get past there, right? So the second part of these questions were find the percentages, the percentage change. So the first test had a 2.3% percentage increase when it went from 880 up to 924. And then the other one, 775 minus 761.67, all over 775. Was a 1.72% price decrease, depending on which side of it you were. And the cool thing about these questions, folks, is that if you had the test where the price went up on your earlier question, on question number 5, you had the change in price where the price went down. So you got to do one of each, no matter what. Right? If your price went up here, it went down over on question 5, and then here, if your price went down, your question back on question 5 was a percentage going up, right? So I was testing both sides of the coin for you here to see if you could do either way, percent increase price or percent decrease price. So don't be surprised if you see something like that floating around on the next test. But usually, folks, just so that you know, question 8, not a final exam question. Tends not to be, just so that you know. And then last but not least, number 9, depending on which test you had, you either had the break-even question or you had the spoilage question, right? So, if you had the break-even question, you had 1.15 million fixed costs, 11 cents to produce, and you sell at 5 1/4, right? Again, I made it a nice, easy problem since we're just dealing with one product in our chain of Hallmark stores. So the key here is realizing that the contribution margin, folks, $5.14, right? Every card we sell, we make $5.14 because we sell it for 5 1/4, but it costs us 11 cents to make it. And then your break-even question is the fixed costs over the contribution margin. 1.15 million divided by 5.14. 1.15 million. You have no idea how many people told me that 115 million is the same as 1.15 million. Scared me a little bit. 1.15 million, folks, is 1,150,000 divided by 5.14, and when you punch that in your calculator, you get 223,735.4086. And the key to breaking even, folks, is remembering that this represents items, not money. The money we already know. It's $1.15 million, right? That's the break-even number. We know how much we need. We just need to know how to get there. 223,736 cards I need to sell in order to break even. If you wrote this as a dollar amount, I got pissy at you and took off 2 or 3 points because it's not money, it's cards. And technically you need to round the cards to the nearest whole card, always making sure that you round up. So that was the break-even side of it. If you had the spoilage question, remember that when you're doing spoilage, you're always calculating cost plus profit. The cost was $280. The profit was 225% of that. The key is that you need to add those two together. So normally when people lost 2 or 3 points on this question, it's because they forgot to add the cost plus the actual markup. Right, so $630 is the markup amount. It's the profit I want. It has to be on top of the cost itself. The items, I'm losing 15% of them. I multiply by the complement. Again, if you took 15% and subtracted, you got the same number. That was perfectly okay. And then last but not least, to figure out the price, you just divide those two. $3.82 a cookie in order to get your profit according to the formulas and whatnot. All right, folks. I don't ask question 9 in the final exam. So there's no break-even or spoilage questions on the final, because I don't want you to have to try and memorize the stupid formulas that you may have gotten to work with those. So just don't worry about question 9 for the final exam, right? In other words, if you get no note card together for a final exam, you can throw away all of the break-even stuff and all the spoilage stuff, okay? Because that's not going to be on the final exam. All right, well, there you go, folks. That's test 2. Again, please make sure that you add up all of your points and make sure that you got the correct number, right? If you deserve more points because I can't add correctly, please let me know and I will change your numbers accordingly. But Otherwise, that is test 2. Alright? Alright, so. Next steps. Note that we skipped chapter 9, folks. Chapter 9 is talking about business-related, calculations that you will do in business classes that I don't want to spend time on. So instead, we're going to jump straight to chapter 10. And you're going to love chapter 10. Because here's the title, the first word of the title of this chapter.
Simple.
Yeah, that could be misleading.
Yeah.
No, this is all simple, folks. It's just all simple interest. So, simple interest, folks. First of all, note that very rarely is simple interest ever actually used, except at the same time, it is exactly what is used all the time. Which sounds like an oxymoron, but it's not, all right? You would think that since it's simple interest, no one would actually use it, but it is actually the basis for almost all banking that we do. Now, the banking is very, very complicated, but the key is realizing that when you break it down to its base component, eventually you're going to get down to a simple interest calculation at some point in time. All right? So, So when you hear about fancy calculations or fancy things that banks are doing in an interest formulation, so if you're talking about annuities, or you're talking about 401ks or compound interest, or you're worried about, home mortgages or car loans, all of these things, folks, every single one of them, they have a very fancy technique to go about using these calculations, but in the end, everything is based on simple interest. Okay? And at some point in time, we can break it down to that. Now, here is simple interest in a nutshell. And this is why it's simple. Maybe not quite as simple as what we got to do back in chapter 7 and 8, right? Where we're talking about selling price equals cost plus markup. I mean, that's maybe a little bit simpler than this. But this is pretty basic, right, folks? I mean, is there anything fancy going on up there? Are we taking anything to a power? Are we doing any kind of square root crap? No, right? It's just multiplication straight up, all right? So all you guys need to do is tell me, what do those letters stand for?
Principal rate of time.
P is principal. Please note that it's the principal that's the principal, not the principal who's the principal, who's your buddy at school, right? So it's principal. Now, what does principal mean?
The amount you owe.
Or,
Or you put in.
or you invest, exactly, right? So the principal is the initial amount you invest or borrow. So note that simple interest works both sides of the banking world. Whether you're on the investment side or the borrowing side, simple interest is simple interest is simple interest. Okay? So the key, though, is just realizing that the bankers will all call it principal, right? And regardless of whether they're lending you the money or you're investing the money, they'll still call it principal, okay? So realize that's the term that they use. And they are really, really, really trying to sound fancy by saying that word, okay? They will say, well, the principal of your loan is $172,000. And that's just them telling you that you borrowed $172,000 to buy your house, right? I mean, that's all they're saying, all right? Anytime you see R in a math formula in a business class, it's almost always rate. Almost always. Please note that the rate will be a percentage, but in this formula, guess what it's going to be written as? That's right. And this is why I don't have to ask you, what is 4.425% as a decimal, because I'm going to ask you questions like, the interest you get paid is 4.25%. And you're going to have to be able to calculate the number correctly, so you're going to convert 4.25% into its decimal and calculate it. T, of course, is time. And please note that in this formula, time must be in the units of years. Okay? And let me remind you a few things that you know, just to be safe. Please remember that there are 12 months in a year. And so if I tell you that you're borrowing or investing money for a certain number of months, that you convert it into years correctly. Okay? In addition, technically there are also 52 weeks in a year. Again, that one I don't necessarily know that everybody has on the tip of their tongue all the time. But if you are borrowing or investing money in terms of weeks, the way you convert weeks into years is by using that there are 52. Please note, you do not convert weeks into days and then tell me how many days there are in a year. Okay? If your units are in weeks, stay in weeks. Okay? Likewise, if they give you months, don't tell me that there's 30 days in a month, right? Because there's a whole butt ton of months that don't have 30 days, right? So when you say 30, there's a good chance you're wrong. Do not convert between units other than going back and forth to years, which is what we need inside of our formulas. And then last but not least, of course, yes, please remember that there are 365 days in a year, but that technically sometimes bankers cheat and say that there are only 360 days in a year. Why do you think bankers use 360 days instead of 365?
Holidays.
Well, what they're trying to do is to make life easy for you, right, Christy? So if you think about it, how many days are there in a month normally? 30. And if there were exactly 30 days in every month, how many days would there be in a year? 360. So basically what bankers are doing is saying all of these months that don't have 30 days in them, they're just stupid. From now on, we're just going to make every month be 30 days. Screw it. And they can override, reality and everything else. So bankers will believe that there's only 360 days in a year. It's not what they're really doing. But the idea is that that's what they're doing, is trying to simplify the problem by saying, look, now you guys can say, whenever you're dealing with interest, if it's 6 months, you can say, oh, well, there's 30 days in a month, and there's 6 months, therefore 180 days. Boom, we're done, yay, right? And everything would be happy, right? When you have to deal with 365 days, if you have 6 months, yeah, is it exactly half?
Yeah.
In fact, it can't be exactly half, right? Because if you think about it, you'd have to have a half a day in there, right? So if you had 6 months, you would never be at a half of a year. Well, isn't that stupid? Every banker in the world agrees because they're nice. They want life to be easier for you. And if you believe that, when I got swampland to sell you in Florida, or a bridge to sell you in France or whatever, I swear I own it. I'll give you the rights. Okay? Yeah. The reason bankers do this, folks, is because they can charge you more interest when they do it. That's why. Okay? When you have 360 days, if you borrow money for a number of days, you actually pay it at a higher rate if you use this number than if you use 365. It's actually been outlawed. All banks now have to use 365 days in a year. Only a very few specific types of lending agencies, i.e. payday loan shops and cheap loan places will use 360 days in a year. And they can still get away with it because they're not banks. They're not being federally protected by the FDIC, or they're not being regulated by the Bank of America, the United States Bank, right? All of that stuff is underneath the rug. But
We'll use 365.
sometimes you have to be able to deal with when does it happen, when is it going to be 360. So here's the key here, folks, right? Star. They're called banker's days. When you hear someone say, please use banker's days, that's what they're saying. They're saying there's only 360 days in a year, right? The other way that you can use banker's days is if your interest is called ordinary. So that's the key word. If you see it say that your interest is ordinary interest, then your days will be calculated using 360 days in a year instead of 365. Okay? So we'll do a couple of examples so that you can see, but that's just the way it works. All right? All right, so not too bad. All right, so best way to do these is just crank out a few examples, right? All right, so let's suppose that I invest $5,000 at 3 3/4% interest for 2 years. How much interest do I accrue? And there's another great word for you there, folks, accrue. Essentially, that's the phrase that means accumulate. It's just that it means a very banking-specific term for how much interest am I accumulating. So if anybody hear anyone say the word accrue, it's just money accumulating for an interest, either payment or credit. All right, so I'm assuming if you get a question like this, that you guys will probably do it in the fastest and shortest possible way to do it. Please note that I will do it the longest possible way in class, just so that I make sure you guys can all see what I'm doing and know what's going on, all right? So the way I attack these problems is that I will start and say, oh, what do all of my numbers represent? Okay? Right, so if I invest $5,000, what does that number represent? Principal. So I will literally write down that the principal, P, is $5,000. Okay? Again, this is overkill, folks. You don't have to do it. This is just the way I'm going to do all the problems in class today. All right? Now, 3 3/4%. You need to write that as a decimal. How are we going to do that?
First, you convert it to something better than that. So
Okay.
3.75.
Okay, so we can convert it to 3.75, but please remember it is still a percent, right?
Then you move your decimal 2 places.
Then move your decimal 2 places and tell me that it's 0.0375, okay? So again, there will be problems like this floating around on the homework so that you guys can do more of these. Be ready. And then, of course, time is 2 years. And how many years are there in 2 years?
How many years are in 2 years?
Yes, how many years are in 2 years?
2.
2. Okay, good. Whenever you're dealing with time, you should always make sure that you ask, how many years is it? So, in this case, I was just making sure that you knew how many years were in 2 years.
I was making sure you knew what you were saying.
All right, so then how am I going to calculate my interest? Yeah, just multiply it, all right? Because the formula is I equals PRT, so 5,000 times 0.0375 times 2. Simple. And hence, now you know why it is simple interest. All right? And unfortunately, yes, it does get more complicated. But this is really what you're trying to do. All right?
Not to get there a little bit.
I'm ready.
Wait, so are we gonna, go ahead.
The 375, that got tacked on to the principal, and that would be like how much they have to pay after
Well-
2 years.
Since I'm investing,
Right.
this is the interest that I earn.
Okay.
So it gets tacked onto my $5,000 when I'm done. So they will give me $5,000 that I invested back and the $375 on top. All right?
So will there be any questions where it's like, I heard,
Yes.
I heard, blah, blah, blah.
Yes.
Oh,
Of course.
but that's not simple.
Exactly. That's for next time. Next time it gets less simple.
Oh, okay.
But today it is
But it'll
just
be on our
simple.
homework though, right?
Of course, yes. All right, so let's try another one. Let's borrow this time, right? Okay, so this time I'm gonna borrow. How bad off was I, guys?
$250,000.
Indian, one of those Indian casino loans, so go crazy on interest.
All right, let's be relatively. Let's suppose I had to borrow $1,000 at, let's say, 27.5% interest for 18 months. Find the interest. And since I'm borrowing, now the interest is going to be stuff that I owe as opposed to what I earn. Okay? All right, so what do I have?
Principal is 1,000.
Principal's 1,000, good.
Rate is 27.5%. Make that 27.5, doesn't, to 0.275.
Okay, good.
I'm a little confused on this one. Time, it says 18 months.
Yep.
But don't we convert it into years, so wouldn't it be 1.5 years?
And how did you get that?
I took 18 divided by, what was that number?
Yeah, how many months are there in a year?
12.
Oh, yeah, 12.
Sorry.
And yes, 18 over 12. In this case, that's a nice number. I borrowed it for 1.5 years. And now you can just crank it out, right? So I is going to be 1,000 times 0.275 times 1.5.
$412.50.
412.50. What? Please know, folks, that when you are borrowing money, you don't just pay the interest. You also have to pay back the principal. So note that when I closed this loan, when I pay it off, I would have to pay the $412.50 in interest plus the $1,000 that I borrowed on top of it, right? Principal and interest when you borrow money. It would be nice if all we had to do was pay interest, but it doesn't quite work that way. All right, so not bad. All right, so then let's suppose that I borrow $500 for 40 days at 22% ordinary interest. What's the interest on this? And now here's folks, when you start getting into days, This is when you have to determine which number of days am I using, 365 or 360. Now, in this particular one, which one am I going to use?
360.
And why am I going to use 360?
Because it's ordinary.
And there's the key phrase, folks. And this is actually how the payday loan shops do it. When they give you the interest payment or the big, huge contract that you sign for how you're going to pay back to them, they will somewhere in there tell you what the ordinary interest is. And the word ordinary is what tells you they're using 360 days in a year instead of 365. Okay? They don't have to tell you anything else. All they have to do is use this word ordinary. Supposedly, that's enough to let you know that they're cheating, or that they're making you pay a higher interest rate. Okay? They actually lobbied with the federal government such that their contracts only had to say the word ordinary. They used to, 6 years ago, have to say, we use banker's days. That used to be the phrase they had to use. And apparently that phrase was enough to get consumers to ask, what does it mean, banker's days? And then they would legally have to explain it to you. But then a couple of years later, they lobbied to just change it from banker's days to ordinary interest. Nobody asks anymore. Because we just read ordinary interest and say, oh good, it's ordinary, sweet. What we don't know is that that means it's only 360 days, right? So, folks, let's do the problem though, all right? What's my principal?
500.
$500. What's my rate?
22%, which goes
0.22. What's my time?
Is that 40 divided by 360?
Yep.
It's a bad number.
40 days or 40 over 360 years.
Are you allowed to round?
No, you are absolutely not allowed to round. You must enter in the fraction 40 360ths.
Okay.
So don't round, don't convert this to a decimal and round it, because then you will probably be rounding a penny or two off, and then you start getting sued by the SEC.
I got 0.1 repeating.
Now, once you get to dollars, then you can round, right? So you're going to say, oh, interest, this is 500 times 0.22 times 40 over 360.
That's awful.
Please remember, folks, that this fraction bar, it's also just a division sign, right? Right, so you can just type in 500 times 0.22 times 40 divided by 360. That's perfectly fine. I would rather that you use this as a fraction itself, but I know most people look at fractions and go, ah! And so I understand that.
Jeez, dude, you scream like a girl.
Yeah. How else should you scream? Should I scream like a guy? Oh, is that better? 500 times 0.22 times 40 360ths. So you got 12.2222222222222.
Yep.
This represents money, folks. You know where to round money. Just in case you didn't have enough twos.
Is that like daily?
No, this is the interest you owe over the 40 days. Oh. No, it's not that, right? You only borrow it for 40 days. It's not like you're, buying a house for 40 days.
My brother-in-law did one of those crazy loans, and he wound up paying for like 3 years on just the interest, and then eventually, like, he just stopped paying, and then they tried to sue him, and then they didn't want to go through with it.
A lot of them, once they start seeing you're almost chapter 11 or chapter 13, they'll just be like, okay, we got that much out of you, we're happy. But they will annoy you forever, just so you know.
Oh yeah.
Yeah, they'll never stop calling. Because they actually sell that paper to a collection agency who will continually be able to call forever. By law, they can too. It's really annoying. So anyways, the key though is realizing that 40 days when it's ordinary interest, 40 over 360. Okay, let's do one more. So let's suppose that I borrow, $800 at, let's keep it simple, 25% interest on May 5th of last year. I paid off the loan on July 23rd. How much did I pay? Now, first off, folks, do you see the word ordinary?
No.
So how many days are there in a year?
365.
365, okay? It must say the word ordinary for you to use 360. If you don't see the word ordinary, it means exact. So 365 days, all right? Now, why is this one a little bit more annoying than the last one?
Because you have dates and you have to figure out the dates.
Yeah, exactly. You actually have to calculate the days, all right? Now,
Did you pay it off on like July 23rd
Yeah.
of 2018?
yeah, same
Yeah.
year. Yeah. It's not, we're not going to the future yet.
Hypothetical,
So-
like,
You take 31 days minus
just make
5
sure
for
you
May,
know,
right?
This is so simple.
And you get 26, and then you add 26 to the 23 to get.
You guys have your little pamphlets?
Yeah, somewhere.
Got all the days in there.
Yeah, I don't know what that is.
I keep mine in myself.
Add it up.
Get that one.
From now on, folks, please bring the little pamphlet to class. We will be using it every day from now on out. All right? I do have spares of these. I've got printed out copies. I even have a couple of these, Monroe, at the front desk, so you can ask them if you don't have this. But I've got them over here if you ever forget. What they have on the back of this pamphlet, the very last page, is what's called a Julian calendar. A Julian calendar is just a calendar that counts the number of days to any date during the year.
Does it include leap year?
No. I will never ask you a leap year question, ever. So you don't have to worry about it. I'm not that much of a dick. I mean, I'm close, but I'm not. So the way you calculate the number of days between two dates, folks, is you just look up the two dates in the Julian calendar and subtract. Because, let's look up May 5th. Basically, May 5th is the 125th day of the year. July 23rd. Is that 203 or is that 204? That's 4, right?
204.
204. That's the 204th day of the year. How many days are there between the 125th day and the 204th day? (204 minus 125). There are 79 days between those two dates. Whenever you need to calculate the number of days between two dates, folks, please pull out the Julian calendar. Please note that from now on every test, you get to use this pamphlet, so you will always have the Julian calendar with you. Okay?
Do we use it for anything else in the
Pamphlet? Yeah. Yeah. Lots of stuff. So all of these tables inside of here, you're going to be learning how to use most of the tables inside of here to calculate numbers without having to use exponential functions on your calculator. All right? So anyways, this is how you calculate the number of days. Please note, folks, we're going to learn on Wednesday how to deal with this when these aren't the same year. When they're in the same year, you can just subtract. When the two dates are not the same year, then it's a little bit more complicated. All right? But if we wanted to calculate the rest of this problem, folks, then it would just be I is 800, right? Is that what I said? Yeah.
Uh-huh.
R is 25%, 0.25.
You mean P, right?
Yeah, P.
Oh, okay.
Alright. And so my T is 79 days. How many years is that, folks?
79 over 360.
Oh, 65.
Yeah, because it didn't say ordinary, 365, right? And then it's just a calculator problem, right? 800 times 0.25 times that wonderful fraction, 79 365ths. Which is weird, but again, remember, it's just times 79 divided by 365.
It's 43.5.
Again, please make sure you round to the appropriate penny. Since it's 43.287, you round it up to 43.29. And then remember, folks, technically, how much did I pay, though?
You have to add that.
$843.
Yeah, uh-huh. Please note that this has a name, which we will also talk about next time. It's called the maturity value. So the maturity value of a loan is just how much you have to pay it off. The maturity value of an investment is how much money you'll have after you're done investing. It also has another name that we'll talk a little bit about as well. It's the future value. It's how much money this loan is going to be worth the guy lending it to you in 79 days, right? It's an $800 loan, but in 79 days it'll be worth $143.29. Hence, we often call it the future value as well. Just realize that those two things, principal plus interest. All right, and this gets us started on Chapter 10, folks. We will finish up Chapter 10 on Wednesday, and then the homework for Chapter 10 Wednesday will be due next week on Monday.
Right.